Hello there, my name is Eric DiGiovino, and I'm presenting today what I call the Darwinian Brain. The objective of this project is to design an artificial intelligence entity that can learn like a human, but without using pre-structured data. By pre-structured data, I mean things like Siri, IBM Watson, which we'll get into later. Those things use pre-structured sets to define their output. Now, my hypothesis is that using a set of self-defining fluid neural networks, we can achieve this with using less code and not defining what the system structure actually is. Now, here's my methodology for conception. Number one, learning. How do people learn? People learn by a form of one thing, immersion. You can do immersion learning by initializing three different things: sight, sound, and cognition. Sight, the person has to see it. Sound, the person has to hear it. And cognition, the person has to be thinking about it. Now, you can initialize these in any artificial intelligence system. To do that, though, you have to have lengthy amounts of data, and that's not fun. My objective here, using learning, is to make it smaller. Now, how many variables do we consider whenever we make a decision? Anything that you see right now is a variable. Anything that you hear at the moment is a variable. Anything that changes in my voice changes your interpretation of what you understand. Now, step two is consciousness. What is consciousness? We can simply define consciousness as the ability to think and to think about thinking. What that means is that little voice in the back of your head when you're reading, that is your consciousness. You are able to think about the reasonable, logical process you are using. And how do we regulate it? We can regulate consciousness in an artificially intelligent system by predefined sets. A predefined set would be, let's say, whenever someone says something, it'll do an action. That is a predefined set, which would be unconscious. Now, if the system makes its own decision as to what to do, that is conscious. Morality. What is morality? Let me put one thing aside. People are not born with morals. People are taught morals. If you have a friend that's a drug dealer, your moral of drugs okay is going to go higher. Whereas if you have a friend that might be the president, you'd have that moral of drugs being okay a little bit lower. But how is it taught? It's taught through interaction with other people. You can teach it to a robot by having the person interact with it. That's another part of our objective, human-like learning. Step four is evolution. What is logical evolution and why is it wrong and right? Most forms of computer science incorporate a form of EA, evolutionary algorithm. What these algorithms do is they take a random set of variables and they reorganize them so they're not random. But it does this over and over again until it gets a logical output, which is the target. That's not how it's supposed to work at all. It's supposed to be reasonable, logical, from input to target. Now, how can natural selection be represented? How can it actually help us? Natural selection, in this case, allows us to control a neural network, or set of neural networks, to define what nodes, what data parts are not needed, and what can stay. What this allows us to do is it allows us to define the size, breadth, scope, complexity of a network, and define it to something that we actually can use instead of being inefficient. Methodology in the application. Step one is fluid neural networks. What these networks can do is they can adjust the size of their inputs, the size of their hidden, and the size of their output. This is really great whenever you're using humanoid systems because we always consider a different amount of variables for each and every interaction. And it also takes a different cognitive process to do each one of those variables. Now, if we use a fluid neural network, what we can do is we can adjust the size of an input to adjust to those variables, have the hidden neural network be saved from a previous, and be implemented as needed for those same types of variables. And that output would be logical and different from any other output. Step two, targeted back propagation. Traditional ANNs are 3 layers, or multiple layers, but they do not have multiple networks in their sets. What I mean by that is, a traditional network might have input layer 1, input hidden layer 2, hidden layer 3, and then output. But backpropagation goes from output to hidden to hidden to input. Targeted backpropagation is input, hidden, output, and several in between, which is what we would need. Targeted backpropagation, what it does is it goes to the separate network and can actually access it, not just going through the whole system, which is traditional backpropagation. And the reason why it needs to be directed and targeted is, if one network already works, why are we going to readjust all the values in that to just the second network? The second network is the only one that needs it. Part 3 is network self-definition conditions. Under what conditions will the network either apply a new network, build nodes, reduce the amount of nodes, or change a trait in that network? That is what I define as a self-defining network. How it works is, we have a set of variables. Once one of those variables are met, a new node or new network will be created. However, it is very difficult to define these. So the first one that I've come up with is, if the system recognizes a new variable state, it creates a new interpretation. Step 4 will be further experimentation. This is how we just piece and part the pieces together. We need the networks to interact with each other the way we want. This is very difficult, which is why it is left blank in the information section. It could take years, or it could take months, or it could take decades to complete this. But if it's done right, the system will work as planned. The originality. IBM's Watson, which goes on Jeopardy, wins every time. How? It wins because it's pre-structured with data sets, input to output. Not to mention it also cheats by having the entire database of Wikipedia. I've done the research. Siri, however, from the Apple Corporation does a similar idea. That's why you need Wi-Fi, because that voice input is sent through a neural network to see, hey, and then it's run through just an AIML, artificial intelligence markup language, which is essentially I have an input here, and this is the proper output for that. That's a predefined structure. That means that it doesn't even know what it's doing. The biological application of this is numerous, because this AI, should it work, can do anything. If you teach it properly, it will be able to do anything you need it to and everything you need it to. So the biological application of this ranges from telling you the atmospheric data 2 months from now to telling you what the soil pH just by looking at the grass. Thank you.
Oh, wow. Nice presentation, yes, sir. Questions? Okay, big
Well, actually,
question.
it's more for the sheet. When is the company supposed to be on the grading thing?
Okay, ask him. Well, you're supposed to talk about the company where you're supposed to sell your ideas, right?
Yes,
Okay.
I would. Personally, this application could go to any company you really want. It could go to NASA. It could tell them how to launch their space shuttles better. It could actually run the fluid networks. It could tell them how the piping actually works. It could also go over to, let's say, national defense and tell us how to better organize our troops, tell us how to better communicate with satellites. It could completely remove the P versus NP equation, which is everything to a cryptographer.
David? Okay, sorry.
Every single corporation that has a duty to do would want this.
All right, any other question? Yes.
Question for you is, how do we rate the teamwork?
Yeah, he doesn't have any teamwork. He's by himself, so it's how he presented. It's basically it. Yeah,
So should
part
we
of the
do that
thing.
way?
No, you can just give whatever. My question to you, Mister. Okay, so seems like this is a very robust program, right? So far, what has been applied now,
Yes.
most currently, like if this is as good as it sounds, right? Why is it that the computer world is not, or I haven't heard of any of these success of this kind of
Yeah,
endeavor?
the reason why you haven't heard of it is because not many people are trying it. Artificial neural networks are notoriously hard to program in large conglomerates. But Google Deep Dream uses a backwards version of an artificial neural network to take an image and show you a hallucinogenic version of that, which includes animals. But no one's doing fluid neural networks because they don't see a need to. They also don't see the need to do self-defining neural networks yet.
Neural networks take a lot of processing power. Do you think with your implementation of neural networks, would it require more or less?
Depending on your design and what you would need it to do, it would take, or it would actually be able to optimize itself to not need as much processing power.
Do you think that this type of biological neural system, do you think it would be better like it would supplant the AI that it was like working with that right now is like super robust?
Which Google AI?
It's I forgot the name, but it's a Google AI that has been able to do dreams and
Yeah, Deep Dream.
Deep Dream.
Yeah. Deep Dream is just an image processing program that works backwards. What they did was they trained a network forward on animals, and they essentially removed the input layer and replaced it with the output layer. So now it works the other direction and applies animals to an image.
Okay.
So at the end of the semester, what can we expect out of your
You can expect to see
ANN?
what you can expect to see is a fluid neural network that can add another network to hidden nodes and output nodes.
That's your design,
Yes.
new design. Okay. Expecting that. Good. All right.